Hello and good morning. These are two more problems that are going to be on your performance matters that you need to do. Remember, performance matters is open. Do not submit it until you're finished the whole thing and you have till the 21st. Okay, so write this down. Performance matters and you have till the 21st. No more time will be given, so don't put it off. So let's take a look here. On this one right here, let's see what's going on. It's a quadrilateral, and then it says arc AB is 104. So arc AB is this one. So put 104 right here. And then it says the measure of arc BC, which is this one, is 88. So label that. It says what's the measure of angle ABC? ABC. So they want this angle right here. Now, let me take a look here. If you look at this one right here is an inscribed angle, which is what we're going to be learning today. Okay, so the vertex right here is on the circle. So it's half of this big arc right here. And that's called the intercepted arc. So if you add that up, I guess you get 192. So this big arc is 192. And the formula is the angle here is half of the intercepted arc. So it's going to be 192 divided by 2. Write that down and memorize it. So that angle is going to be 96 degrees. There it is. And that's what we're doing today. This one right here, you had this one. Now look, if this tangent from here to here is 8, so is this one. So put an 8 right here. If this one is 12, then so is this one. And then 16 minus 12 right here is going to be 4. So this one is 4, and this other one on the other side has to be 4, and you add them all up. So it's going to be 12 plus 8 plus 8, and then your 4s. And you add all of that up, and you get your answer. Well, this is 20, this is 20, and this is 8. So that's going to be 48 inches is the perimeter. All right, let's talk about today's work, which is inscribed angles. So copy down everything you see right here. All right, I'll make it a little bigger. All right, so a central angle is where the vertex, this is called your vertex, where it turns, where your vertex is the center of the circle, which is why it's called central angle. An inscribed angle has the vertex on the circle. So, if it's a central angle, the angle and the arc are the same. If it's an inscribed angle, like if this is 40 degrees, the arc would be twice as big, which is 80. Okay? So if they give you the arc, you take half and you get the angle. If they give you the angle, you double it. The arc is always bigger. So let's take a look at this one. It says the measure of angle RST. So R, it's actually arc. RST. So it's this arc right here, starting here and going this way. So they tell me this arc is 164 degrees. They want me to find the measure of angle RVT. So R, put your pencil on the R, go to V, and go to T. Notice that the vertex is on the circle, so it's inscribed, and it's half of the intercepted arc. Well, you just take half of 164. And that's going to be 82 degrees. There it is. And that's how you do it. Okay, so if it's an inscribed angle, you take half of the arc. One more. If you look, I know this looks strange, draw that diagram, but this is actually an inscribed angle. The vertex is on the circle, so it's going to be half. So they want you to find arc XZ. They want you to find this right here. Well, if the angle is 50, you got to double it and you get 100. It's an inscribed angle. Remember the relationship. One more. This one is an inscribed angle. They give you 60, so you double it and get 120 degrees. Remember, the angle is equal to half of the arc. Write that down. Here's your assignment for today. Let's turn our attention now to MCR. So I want you to factor these. Well, this one, I know this one has a 4 in it. 2 times 2 and then x. This one is 2 times 10 and 2 times 5 and x. So I'm circling what they have in common. Well, they have 2 2's, which is 4. 2 times 2. And then they have 1x. So that's your greatest common factor right here. And what's left is x minus 5. And you're done. This one, they only have an x in common, so you take the x out and you're left with 10x minus 1. Today we're doing difference of 2 squares. So on a new sheet of paper, copy these down. Okay, so the difference of 2 squares means this one has to be a perfect square, and it's got to be a minus. 11 times 11 is 121. 7 times 7 is 49. So it is the difference of 2 squares. So your answer is going to be a plus and a minus. 11x plus 7 and 11x minus 7, and you're done. This one right here is going to be 5x minus 1 times 1 is 1, so it's going to be 5x plus 1 and 5x minus 1. This one is not a perfect square, nor is that one. But if you take a 2 out, if you factor out a 2, then it becomes x squared minus 25, and that is a perfect square, or the difference of 2 squares. So that's going to be x plus 5, x minus 5, and then the 2 is part of your answer. And that's how you do that. Today you have a worksheet on the difference of 2 squares. And it's right here. If you get stuck, I want you to ask for help. Okay? When you're done, find something to do quietly. No electronics. Here's the rest of it. And there we go. Okay, so have a good morning, and I'll see you in class.